Hello everyone! Is it possible not to be able to integrate each function? In other words, do we have antiderivative for each functions? The answer is no. Sometimes we do not have antiderivative for functions. Sometimes we cannot integrate functions. For instance, look at this question. Look at the inner integral of the double integral. We have sine y square, and it's not possible to integrate sine y square. It doesn't matter which method you use, it's not possible to integrate sine y square. So we have this kind of functions which is not integrable, which are not integrables. Okay? So in this case, we have to change the order of integration. So how do we change the order of integration? I strongly recommend you to sketch the region of integration if you have this kind of problems in double integrals. Let's have an xy axis. Let's have an xy axis here. And look at the boundary of the inner integral. You have y equals x and y equals 1. And be careful here. The inner integral is computed or is set up with respect to the variable y. It means you have to draw a parallel line to the y-axis. This is the parallel line to the y-axis here. Okay. Then look at the boundaries of integral. You have y equals x. You have y equals x. Sorry. This is y equals x. And the upper bound of integral is y equals 1. This is the upper bound of the integral. Y equals 1. Okay. The inner variable is with respect to the functions, and the outer variable is with respect to the numbers. So you scan the region throughout the outer variable. For instance, here you have x as the outer variable. So you scan the region through the x-axis from 0 to 1. From 0 to 1. This is the point 1. Okay? For 1, you have 1. So this is the region of integration for the double integral. Okay? As I told you, it's not possible to integrate this double integral. This is why we change the order of integration. So this integral is equal to, this double integral is equal to, we don't change the function at all. So sine y square, we don't change the function, but we change the order of integration. Instead of dy dx, we have dx dy now. So since we first compute with respect to the x variable, or since the variable of inner integral is x, we draw a parallel line to the x-axis now. Let me clear. We now draw a parallel line to the x-axis. This is the parallel line. Since we first compute with respect to x here, okay, and x is from. This is the point where we enter to the region. X is from 0. This is the line. The y-axis is the line x equals 0. Okay, and this is the point where we check out the region. X equals y. X equals y. What about the boundaries of outer integral? We scan the region throughout the y-axis. That is, y is from 0 to 1. Y is from 0 to 1. Now we have a reversed version of the given double integral. Now it's very easy to integrate the inner integral with respect to x. The integral of sine y square with respect to x is x times sine y square dy, and don't forget to write the boundaries of integration. X is from 0 to y. Okay, so this integral is equal to, and y is from 0 to 1. Y is from 0 to 1. We will plug the values of x here. Then we have y times sine y square. For 0 you have 0, this is why I don't write 0. Then if you look at the rest, it will be enough to change the variable, to substitute, to use the substitution method for the integral. So let's use the substitution method here. Okay, so let's say y square is equal to u, 2y dy is equal to du. Okay, so, and u is from 0 to 1. Okay, by simple calculations you will have from 0 to 1. Instead of y dy, you have du over 2 here. Instead of sine y square, you have sine u. This is equal to, what is the antiderivative of sine u, or derivative of which function is sine u? Derivative of minus cosine u minus cosine u. What was u? Or it doesn't matter, you write u or y square here. Cosine u from 0 to 1. Don't forget to divide by 2. Okay, and this is equal to the parentheses of minus 1 over 2. You have cosine 1 minus cosine 0, which is 1. Okay, it is the answer of the solution. I hope you understand. Now I want to find the integral of the last problem. So again, I want to have an xy axis here for this problem. This is the xy axis. I think we need another type of xy axis, this type. Okay, this is the xy axis. Okay, since we have absolute value function here, okay, it will be very good to write the given absolute function explicitly. So this function means, this one means that you have 4 equalities. X plus y, you may have x plus 1, x plus y is equal to 1, minus x plus y is equal to 1, minus x minus y is equal to 1, and finally x minus y is equal to 1. Okay, by this equality you have 4 equalities. So I need to draw these 4 lines. X plus y is equal to 1. X plus y is equal to 1. I think it is something, oh sorry, it is something like this. Okay, let's say it's something like this. minus x plus y. This is minus x plus y. Okay, minus x minus y, minus x minus y here again. Sorry. No, I am not. I am very bad at sketching the graphs. Very bad. This is, let's say this is minus, no. Let's not change this. Okay, this is good idea. And I need to change this a little bit. Okay. This is minus x minus y. Let's say this is minus x minus y. I know I am not so good when we talk about sketching regions, but finally I have to draw this line. I have to draw this line. Okay. Okay, finally. This is minus x minus y is equal to 1. Okay. And this one is x plus y is equal to 1. That one is minus x plus y is equal to 1. And finally that one is x minus y is equal to 1. So the rest is just to set up the double integral. As you see, we have the double integral over the region R, but the region R is not so easy. The region R is complicated. As you see, if you first want to write, let me write the function here to x squared. Okay, this is the function, we don't change the function. If you first wish to write the x, for instance, then dy, let's say. So you have to draw a parallel line to the x-axis, Let's say this is the parallel line. And you will check the point where do we enter the region and where do we check out the region. This is the point where do we check in or enter the region. This is where do we check out the region, okay? But if you draw a parallel line here, you will see you have a different you have different points, okay? This is the point where you enter, this is the point where you check out the region. So it seems either you compute the double integral first with respect to x or with respect to y. You have two regions. You have two regions to compute. So let me clear the xy axis, okay? Then continue. Okay, I want to compute the double integral first with respect to y, then with respect to x. So this is the given double integral on R is equal to, let me write down here, is equal to, okay, don't change the function again. Now I write the variable of inner integral. Let's first compute with respect to y, then compute with respect to x, okay? Since I write the variable y for the inner integral, I draw a parallel line to the y-axis. This is the parallel line to the y-axis. and this is another parallel line to the y-axis, since we have two regions. Let's say this is the region 1 and this is the region 2. Okay, region 2, this is the region 2 and this is the region 1. We have two regions. So on R1 we draw a parallel line to the y-axis, as you see. Okay, where do we enter to the region? On this point. So y equals, you have the boundary of integral as y equals minus x minus 1 minus x minus 1 to the curve 1 plus x. 1 plus x. What about the region of x? X is from minus 1 to 0. Okay? X is from minus 1 to 0. So it is for the first region. This is for R1. Okay? And for R2 we have, don't change the function again. Don't change the order of integral. For R2 we draw a parallel line to the y-axis, as you see. This is the point where we enter to the region, and it is on the curve, on the line x plus 1, x minus 1, sorry, y is equal to x minus 1 to, look at this point, you have y equals 1 minus x, 1 minus x, and x is from 0 to 1. X is from 0 to 1. This is a double integral for the region R2. And I think it's very easy to compute the rest of the problem. You have the order of integrations, you have very simple functions to integrate them, so the rest is yours. I hope you understand.